Okay, so I'm going to briefly go over this midterm. So we'll start with problem number 1. This is all of our givens that was given in the problem for the exam. And what we're ultimately trying to do is find the level of service on each side of the road, which has different terrains. So we just go through the processes of finding the free flow speed, then finding our AADT for the year 2026 with this factor right here. And then once you find all these values, you get to plug it in for the, well, we also got to find the DDHV, and then we have to find the heavy vehicle factors for both level and the terrain. Or, sorry, level and the rolling terrain. Okay, then we plug those in for our volumes, both for level and for the rolling. And for the volume of level, we're going to end up with the level of service of B. And then for the rolling, we get a level of service for C, or of C. Okay, then we want to move on to number 2, which was the shockwave theory. And to find this one, you just find begin with finding the density with our given values, which is going to be 16.9. And then you want to find it again for condition 4. And you get to plug all these into this chart to make it easier to see. Then you're going to want to find the length of the cube between both the conditions 1 to 3 and the conditions 3 to 4. Get these numbers, and don't forget to multiply by the 10 minutes that the roadway is shut down to get these values. And then finally, what we're ultimately looking for is how far back it is when the queue clears. So you plug in this equation, which was given to us, and you find out that it is back 1.96 miles from the original crash. Then, for question number 3, we just want to find, this is just a coordinated signal delay, with an error of most of your, 65% of your traffic arriving during a red. So to find this, you just need to find the volume of all the arriving cars, out of the platoon and of what we call V side. And you get all these values, and then we want to find them for departures and arrivals, and we're going to integrate. And all these are for the given values, 0 to 36, 36 to 56, 56 up. And once you get these, you're going to set your arrivals of 56 up equal to our departures. And this is going to give us a T value of seconds. And then we're going to plug that in to find our total delay. That's going to be one of our bounds for these last two. So once you do all that, you just integrate one more time. And that's going to give you these numbers, and you add them together or subtract, whatever you need to do to find your total delay, which we found right here was to be 236.51 seconds. And then I've also attached a figure of, this is all of our cars arriving during red. This is where 65% of the cars arrive during this blue part. Then we got the green time go, and this is where the rest arrive at 56 plus seconds. And the purple is our departures.